questions.
So remember,
Which paper am I on?
The same one.
I just put them
I
on.
wasn't
Hold on.
done.
Which one am I on?
18.
18.
Very nice.
Okay. Which of them is not a property of an ionic compound? Which one did you think?
Either A or C. It says it's brittle, but vaporizes go through committee.
So it's A.
But it's brittle, so how can it be hard?
Well, brittle doesn't mean hard. Have you ever bitten into like peanut brittle? That crap is hard as all, but it's still brittle.
it's disgusting. No, it's not.
I mean, that stuff will crack teeth in a New York minute.
Remember, you said that we can do test corrections on this test.
I just said maybe I'll allow test corrections on
You
this
said
test.
we can do test corrections.
I did not say we can. I said maybe I'll allow. I'll take it under advisement.
Listen, I love my butterscotch and cinnamon hard candy. I even
I don't like butterscotch.
Allow you
The coffee
throwing.
ones are good.
Yeah, notebook.
I got chocolate.
Or the mother.
You got chocolate.
Yes, I was back.
I had like the one you run into is like this.
Those are
I
a
ate one in Picky, and I got where? No. It was
Oh, you talking about in middle school, elementary? I thought you was talking about in high school.
You coming to warm up?
No, I just felt like it was warmer in my room, and I'm just coming. The kids say it's my imagination. So it is kind of warm in here. Yeah.
It's much warmer in here than your room.
I'm cold.
I love them.
Why is your room so
It looks wrong.
They just said they were building.
It be like showing up.
They probably did.
I was scared. Oh, afterwards?
When it finally came up, that's why you they were so sweet. Oh my God, that was so scary.
Oh yeah, it's a lot warmer over there. It's not our imagination.
It's warm in there?
Oh no, it's warmer over there. It's warm in here too.
Is it warmer in there than it is in here?
Oh, no. It's not warmer over there. It's just warmer than it was.
It's still cold.
It's still cold, but it's not anything like it was. No, it felt like you were outside when I got here this morning.
This is when the map comes back, right?
Yes.
Are you serious?
We have probably, I don't know, 45 minutes of note kind of theory stuff to do, and then pretty much just learning some math formulas. There's some theory that goes in. There's some theory that goes in the formulas, though, Diamond. Okay. Diamond, did you hear me?
Yes.
There's a little bit of theory that goes to the formulas early.
So that was like history and jokes.
No. Just how the formulas work, like who's inversely, who's directly proportional, kind of stuff that we got to do. Well, you might need to know it for the exam. But beyond that, most of it is math. Okay, it's heavy on the math for a week and a half. So this test will be 20 points worth of multiple choice. So 10 multiple choice questions on the theory, and then 80 points will be math.
So there's only like 30 questions?
There's only 21 questions. 10 is multiple choice, 11 is free response math.
Yeah, all of the stuff we're learning is connected. 70, that's like unheard of. All the stuff we're learning is connected.
Yes.
I just wish I knew 70 more.
Why don't you go to the office and tell them it's too cold?
I'm not cold. I'm sorry.
Your students are cold.
I don't know what to tell you. All right. So kinetic molecular theory and the gas laws. I know I imagine those how it's connected, but this will actually roll out into what we're doing after the gas laws and as we cruise towards Christmas also. But KMT is the way we write kinetic molecular theory, so we don't have to keep writing out those words continually. We will abbreviate KMT from now until Christmas, okay? But it's the idea that all particles in matter are always in motion. So you're sitting at a desk. It's a solid. Are the particles inside of the desk in motion?
Yes.
Yes. Most of you would argue with me and say, no, they're not. But yes, they are. Okay? All particles in all samples of matter are in motion. So, whoops. Now, we talked about this, and you might see it on the test tomorrow. All right? And that's one reason why I don't mind doing this section today, because some of this is review from what we've already done. There are 3 types of motion. What are those 3 types of motion? Vibrational. All right? Perhaps someone you know who has Parkinson's, palsy, something like that. They vibrate. They shake. So molecules shake. All molecules do this, whether they're solids, liquids, or gases. However, solids only have vibrational motion. And we'll talk about this after we do the gas laws. Okay? But because solids are locked into position, solids are only able to vibrate. So when we're talking about the desk and those particles being locked into position, the only thing solids can do are vibrate in those positions. Now, translational motion, liquids and gases translate. Rotational motion, liquids and gases can translate and rotate, but solids can only vibrate. Now, when does motion stop? We talked about this earlier. I think, maybe not. Maybe I did physical science. I lose track of what I teach in what classes. All right, motion stops at absolute zero. You might know what absolute zero is defined as?
Space.
Zero. Okay, but physical science.
Zero energy.
All right, given the way y'all are all staring at me, that must have been something I did in physical science. It's defined as 0 Kelvin. Okay, 0 on the Kelvin scale is absolute zero. Now, in order to get to 0 Kelvin, and this is a theory at the moment, nothing has reached 0 Kelvin or absolute zero. We have to lower the temperature and the pressure in order to get there. Just to give you an idea at what 0 Kelvin is, 0 Kelvin, because remember we have a formula, K equals C plus 273, so we can easily calculate it. It's negative 273 degrees Celsius. Most of us don't use the Celsius scale, so it doesn't tell us a whole lot. Now, y'all were complaining about 20 degrees Fahrenheit today. Cold, we're going to freeze to death as well, turn the heat up. In order to get to absolute zero, you got to get down to negative 457 degrees Fahrenheit.
What's like the coldest temperature on Earth?
Probably there or the Arctic.
No, but like how close?
It's not that. Nowhere's near that.
That would kill us.
We can't sustain anything at that temperature. When you look at videos and it shows liquid nitrogen, liquid hydrogen, things of that nature, you're not at absolute zero. You're not close.
What's the lowest?
I don't know. You have to look it up. I don't keep those. Yeah, feel free.
Miss Waal,
Yes, ma'am.
can you send Alex Holt to the office?
I will.
Thank you.
Welcome. But you'd have to look it up. Absolute zero, we've gotten close. Theoretically, they've gotten very, very close, but they haven't quite gotten there yet. And there are researchers who work on that all day. That is their life project, is to try to get to absolute zero. They just haven't quite gotten there yet. Huh? They may.
Funny.
Now, so a lot of times people will ask me, are dead people, are their molecules still moving? Yes. If your molecules in your body when you're laying in the casket were not moving, would you be able to decay?
No.
No. If they weren't still moving when they buried you, when they dug you up 20 years later, you would still look as good then as you did when they put you in the casket. And does that happen? No. You have to be able to decay, so your molecules are still moving after you're dead. Okay? So your body is able to go through the process of decay. So our molecules are always moving. Same thing with the death. Now, the molecules are not moving to keep you alive. They're just moving in a way that they're decaying. So, solids, liquids, and gases have motion. I wrote that for a reason. Why do you suppose I wrote that there?
Because someone somewhere did.
They get it wrong on the test every year. What do you suppose they leave off every year on the test?
Solids.
Solids. They tell me solids don't have motion. Okay? I'm telling you now, you're going to see that on the test. In one of the 10 multiple choice questions. I'm going to ask you about which states of matter have motion. All 3 states of matter have motion. It's multiple choice question.
Are they the only states of matter? Or no?
Well, plasma is a state of matter, but it's not part of our curriculum, so I don't talk about it.
That's a fun one.
I know, it's not part of our curriculum, so I don't talk about it.
Basically, it's.
All right. Now, we're going to talk about ideal gases. Now, an ideal gas, first of all, is a made-up gas. I'll just put that out there so you know. All right, but an ideal gas obeys all 5 assumptions of kinetic molecular theory. Now, why on earth are we studying made-up gases? Well, because it makes math easier for Lolly, because she's already, as she says, math challenged. And so we're a first-year class. We're trying to get our feet wet in the gas laws, not work the hardest problems known to man. So, kinetic molecular theory and the 5 assumptions make life a little easier for us so that we can work gas laws that are very life-based, yet still doable in a first-year class. So, we're going to create conditions that allow us to work math problems that are easier. Does everybody have what they need?
Sure.
Okay. So, how are we going to do this? Number 1, we're going to work problems that have a large number of molecules. That is not hard for us. So, our problems might say something like, for example, 1 mole. Well, what do you remember about 1 mole? How many particles are in a mole? That is beautiful, Lolly. 6.022 times 10 to the what? 23rd. That's a huge number of particles. Just by putting in 1 mole in the math problem, we now have a huge number of particles to work with. That's not hard to do in a math problem. That's very manageable. Okay? Is it? Yes. Okay? Now, we're not going to work problems that have few particles. That makes it much harder to do. And we're not going to work those kind of problems. We're going to assume all the gas is moving straight lines. They're in constant motion. Okay? That's the way it works anyways. Gases don't walk up to other gases and go, excuse me, can I go around? It doesn't happen. It's a lot like walking up the main hall during class change. People aren't very courteous. They'll push into you. Well,
they can write out the answers and say, excuse me, it doesn't matter what they do, you still have to realize that person.
I didn't realize I don't know.
Yeah.
all right, last one, and we're going to stop here. It's a new vocabulary word for you. All right, all collisions are elastic. Okay, all collisions are elastic. Meaning there's no net loss of kinetic energy, it's transfer.
I'm not going to finish this medicine.
Yeah, we're stopping there. Okay. Now, in real life, does that happen? No, some of it's going to be lost to heat. Some of it's going to be kept. It's not all going to be transferred to the next person or the next gas molecule. So we're going to make an assumption that that happens. All right? Now, if you didn't get it, I'll put it back up there on Friday. So don't panic. Your homework is to do what?
Study.
Study for the test. If you want help, I'll be here this afternoon. If you need to do any makeup work, I'll be here this afternoon. Some of y'all need to do some makeup work.
I need to call me and I have a game.
I can't fix that for you, Elijah. The time y'all leave. I don't think you can get any tutoring. Good luck, though.
Thank you.
First of all, let me see. Yes, we can do all that. You said NH2P.
Yeah.
So you're gonna have 5 plus 2 plus 5, so you're gonna have 12 electrons. What do you make N the central atom? H, P, 2, 4, 6, 8, 10, 12. Take those two off, put them there. 2, 4, 6, 8. 2, 4, 6, 8. That would work there. So you want to know if it's what?
Polar or non-polar?
Because all the bonds are different.
Okay. Thank you.